Okay, let's go through the next section, which is 2.5, and we're going to be learning two, or actually three different ways to solve a system of equations. We did graphing last time, so a lot of work that we had to do to put into graphing. We had to find out how to graph the equation by putting it into slope-intercept form. That was at least the easiest way to do it, and then be able to graph those and see where they crossed. That would be the solution. So remember that if they have different uh, slopes, there is going to be one solution. If they have the same slope and everything zeroes out, so you get 0 equals 0, then um, then that means that they are an infinite number of solutions. And then, of course, if you end up with something like the slopes end up canceling out because they're equal, and you have 2 equals -3. If it's not true, then that means there are no solutions. So we have a number of different ways to be able to go through it and kind of figure things out, which is important. So the same thing's going to kind of happen here when we start looking at these different types of equations as well. So first thing is that the structure of the presentations are going to be a little bit different. The very first stuff that you're going to see in the presentation is you're going to see some examples. So notice here we have substitution when there is one solution. So we can use substitution to solve this. You can go through and watch the steps as they go through them and figure out how we actually do that. I'm going to explain that when we get to the problems that I'm going to do. So the first slide is substitution when there's one solution. This one is substitution when there's not one, when there is not exactly one solution. And what that means is if we look at this, these two equations actually turn out to be the same. And so if they are the same equation, then that means that there's an infinite number of solutions. So that's what we would do in that particular case. So when we're kind of looking at this stuff, we can kind of get an idea of what's happening with these particular problems. But just so that you understand that and know what it means in this particular case, and I guess I can't undo it. Oh, yes, I can. So let's go to next, the graphs of the equation. So if there's infinitely they are coinciding. So they're with each other. So they're definitely with each other. So don't have to know that terminology, but just so that you have a general understanding, you can kind of see what that all is there. Okay, so moving on to the next one, here's elimination when there's one solution. If there's one solution, that means they cross. It's going to go through the process of elimination, which I'm going to explain. And then we have multiply both equations before using elimination. That will make sense once I get through that material. So you'll see that, but you can follow through the steps here. What's nice about these first problems, it's just a bunch of examples that they do specifically that you can kind of follow through. And it'll make sense again once you listen to what I do in the lecture. And then finally, an elimination when there's not exactly one solution. So you kind of see what happens if everything cancels out. So, and it depends on what happens at the very end. So when we take a look at it, excuse me. So notice here, if we were to do it all, notice we end up with 0 is not equal to 8. So therefore the system has no solution. So we can kind of get an idea of what's going on with all these different ones as we go through it. Okay, so I think we're going to get started. So this will start the process of the videos. And we'll start the videos that will explain these different methods to you as we go through it.